Hello, welcome to my classroom. Today's topic is soil compaction. In fact, in soil mechanics, different terms are used. For example, soil compaction, soil compression, soil consolidation. Sometimes these are used synonymously, but there are, of course, some differences between the three terms. So today we will just study soil compaction because it's more important from agriculture point of view. Its phenomenon, how it takes place, and what is the significance of it. But before that, what is in fact soil compaction? Soil compaction is increase in bulk density of soil with a dynamic load. Dynamic means changing load with dynamic load. For example, if you have an agriculture field, you have agriculture machinery, traffic soul, because of the load of that agriculture machinery, which is not static, which is always changing. So that results in increase in bulk density of the soil. So what we call as soil compaction. That increase could be due to decrease of volume of pores, due to some other reason, but in general we say that soil compaction is increase in bulk density with a dynamic load. Then soil consolidation. What is then soil consolidation? This is in fact soil consolidation is the gradual decrease in volume of voids or pores. Volume of pores, volume of voids. Gradual decrease in volume of pores with continuous or continuously acting static load. So here now you can see the difference. In soil compaction it was dynamic load, which you never know that what is actually the load. The load may be, today load may be something, say X, maybe next day the load could be Y, something like that. But here in soil consolidation, the soil gets consolidated due to gradual decrease in volume of the pores, volume of the voids, with continuously acting static load. The best example is soil beneath a building. Because building is a static load. We know that building is putting this much of load on the soil beneath. And then how that soil gets consolidated, or in other words, from ingenious point of view, to what extent we need to consolidate the soil before putting the building over it. So this is your consolidation. And of course this static load, it acts over a period of time. And the best example is that sometimes the houses, they get cracks in the walls. Particularly in that case, the consolidation has not been done before starting the construction of the building. So some other reasons could also be there, like there could be land deformation, land compression could be there because of the natural reasons. But this happens, consolidation happens over a period of time. Then third term is soil compression. Now soil compression is basically, again, it is change in volume of the soil under applied stress. Applied stress or applied load, you can also say. Now here then you might have a question in your mind, then what is the difference between soil compaction and soil compression? In fact, soil compression, it is increase in bulk density. And increase in bulk density, if you remember my earlier lectures, bulk density is mass of soil divided by total volume. Now this bulk density will increase either in a particular volume, unit volume, you have increase in the soil solids, or you have a decrease in total volume of soil. So when you say decrease in total volume of the soil, then you can say that okay, you might have compressed the soil solids. So here change in volume of the soil means you are compressing the soil solids, and you are also reducing the volume of the pores. So in all these three cases, the same phenomenon is occurring, that if you compact the soil, you are increasing the bulk density. If you are consolidating the soil, you are again increasing the bulk density of the soil beneath. But the process is that in compaction, the bulk density increase could be, the reason for increase in bulk density could be different. Either this or that or both. But in consolidation, it is again gradual decrease in volume of pores, and pores are contained over here in total volume. So gradual decrease in volume of pores, that leads to increase in bulk density again. And in compression again, it is change in volume of soil, again change in volume of soil. But here we actually change the volume of the soil. It's not a natural, you are compressing the soil. Consolidation is a natural process, or you use this natural process in constructing a building. Before constructing the building, you consolidate the soil, because you know this is the compressibility of the soil, this is the extent to which the soil can consolidate itself. So you do it otherwise wrong, that before constructing the building you are consolidating the soil. So I hope the three things are clear now. So in all the three cases, bulk density is involved. Okay. Now the question is that out of these three, soil compression and soil consolidation, these are generally the terms used by the engineers. So we will not be going into details of these two terms over here, because in agriculture, because we are dealing with soil physics in agriculture, so we shall be mainly concentrating on soil compaction. So compaction could be natural, that means you are not artificially compacting the soil, it could be natural. You can also compact the soil artificially, but first of all, under natural conditions, and this is of agriculture significance, that you have certain type of hard pans within the profile, and these hard pans could be genetically induced. When I say genetically induced, it means that the hard pan formed over here, they are basically the result of or replication of the parent material. There could be layering sequence, one layer could be of high bulk density, then another layer could be of loose bulk density, but it is right from the parenthood. It's not because that we have applied or somehow the load was applied and the soil got compacted. This could be genetically. But at the same time, it could also be due to improper tillage operations. When I say improper tillage operations, because for tillage operation to be successful, because one of the major objective of tillage is to create a proper soil, physical condition of the soil, so as to maintain a balance between soil air and soil water. Because in my introductory lecture I told you that if soil water increases, the plants won't be able to respire properly, and at the same time, If soil air is at a of higher content than soil water, again there could be deficiency of water and plants may suffer because of water stress. So in both cases it could be either air aeration stress or it could be water stress. So we need to have ideal composition of soil air and soil water, that is 50%. 50% of the pore space is occupied by soil air, 50% is occupied by soil water. So then when I say improper tillage operations, that means you are tilling the soil at inappropriate moisture content. Inappropriate means either too dry or too wet. So we will just now we will see that when you are compacting a dry soil or when you are compacting a wet soil, what happens? What is the mechanism? Then again it could be due to agricultural machinery. Nowadays the things are mechanized in agriculture. So you have tractors, you have different equipments which are used by the traffic for spraying the chemicals and all that. So agriculture machinery is a major cause of this agriculture compaction or soil compaction. And here when you can say that this is artificial compaction. This could be because you are moving the agriculture machinery, you are compacting the soil. Then it could be because of it, we generally call these as plow saws, very common. Plow saws, in fact, when you till the soil, at the most you are disturbing 13, 14, maybe 15 centimeter of the profile, and the rest of the soil remains consolidated, remains compact. So when you are repeatedly plowing the soil, disturbing that plow layer, that is 15 centimeter, then immediately below the plow layer you have a layer of higher bud density, what we call as plow soil. We also call these as traffic soils. Even if you are using disc plows, then we say this is disc harrow soils, like that. So this is how because of the natural or man-made activities, in fact I should not say completely natural, I cannot say artificial also, because artificial means we are deliberately compacting the soil with certain objective in our mind. But here it's not artificial because we are not deliberating compacting. It gets compacted because of different agriculture operations, or it could be genetically induced soil compaction. Then it could be artificial also, as I said, artificial compaction. In artificial compaction, sometimes you have very coarse textured soils. And the main issue with very coarse textured soil is when you apply irrigation, the water immediately moves out of the root zone and it gets dried up. You have to frequently irrigate such soils. So in order to get rid of that, frequent irrigation, so what we do is that we artificially compact this soil by rolling. So rolling with the help of heavy rollers, this is done to compact the soil. In fact, when we go for rolling, we are basically converting the macropores, which are water conducting pores, into micropores. So when you have a dominance of micropores, then water will be retained, because micropores are water retaining pores. So we are deliberately converting the water conducting pores or macropores into micropores, which are water retaining pores, and this is how we take care of the very coarse textured soils. We are able to manage very coarse textured soils. So this degree of compaction, it could be by rolling, it could be by tampling, it could be by vibrating, etc. Different means we can compact the soil. Now the question is, this degree of compaction, then it depends on the most important thing is the degree of compaction depends upon the type of soil, nature of the soil. And when I say type of soil, I generally mean soil texture and to some extent soil structure. A coarse textured soil can be compacted to a greater extent than a fine textured soil. If you are applying same amount of force in coarse textured soil as well as in fine textured soil, the bulk density of coarse textured soil will increase to a greater extent than that of fine textured soil. If I ask you what is the reason behind it, the only reason is that the coarse textured soils, they are dominant in macropores and you have ample scope to convert macropores into micropores. So you are reducing the volume of macroporosity to and increasing the volume of micropores. So that way those coarse textured soils, medium textured soils, they are liable to be compacted to a greater extent than fine textured soils, which already have a dominance of micropores. So you don't have much space to compact the this fine textured soil. Then similarly soil structure, if you have well aggregated soil, that can be compacted to a greater extent. But on the other hand, if you already have a compacted soil, so naturally if you apply same amount of force to an aggregated soil and compact soil, of course the aggregated soil bulk density will increase to a greater extent than compact soil. So the degree of compaction depends mainly on the type of soil. Then it also of course depends upon your soil water content. This is very important factor. Supposing we will discuss in detail this factor, so let me not discuss over here, I'll come back later on. This is very important factor, and of course yes, it depends upon the amount of force which you have applied. You can say the compactive energy or compactive force. Higher the compactive energy or higher is the amount of force, more will be compaction. So nothing to explain in that. So the significance of this compaction is, I had already discussed significance of compaction in very coarse or coarse textured soils, but in general the state of compaction it determines soil, air, water and temperature regulations. Very important. So in a single line we can explain the importance of compaction from agriculture point of view. Soil, air and water. So to what extent, say you have a medium textured soil, if it is compacted to a greater extent, you can expect more water to be present in the pores than air. On the other hand, if the same soil is not compacted, then you can expect more air than water, because then you will have dominance of macropores. Similarly, when you compact it, you have dominance of micropores, and micropores they retain water, so higher amount of water. So that's why I said that when you plow the soil, our main objective of plowing the soil or tilling the soil is to create a favorable environment for plant growth, for crop plant growth. So that physical environment is, you should have proper amount of air, which is important for the plant roots to breathe. proper amount of moisture, which is important for the roots to take up water as well as nutrients, because nutrients they are taken up by the plants in solution form. And then temperature relations also. If you have a compact soil, you can expect the heat conductivity to be high. Similarly, if you have compact soil, the water content will be more. So the specific heat of the soil could be high than a dry soil, or than an uncompacted soil, or loose soil, or low water density soil. So this is how you can explain the significance of soil compaction in agriculture in a single line. But then you can explain all these factors individually. That's very, very important. And of course, based on this physical environment, soil, air, water, temperature, continuum, you can also say, uh, it determines the physical, chemical, and biological environment of soil. And I said in the beginning in my first lecture that soil fertility, to be a complete parameter, it should be physically fertile, it should be biologically fertile, only then it will be chemically fertile, because chemical fertility, transformation of nutrients, that is determined by the microbes present in the soil, and the microbe population that will be determined by the physical condition of the soil, proper air moisture balance, and proper temperature conditions for the microbes to act. So that's why these three components of soil fertility, I should say better that these are three components of soil fertility. I'm stressing upon this point because generally people believe that soil fertility means availability of nutrients. No, it's much more than that, because nutrients will be available only when you will have a good population of microbes, you will have good population of proper balance of air and water in the soil, temperature in the soil, and of course the presence of minerals in the soil to be transformed into available form by the microorganisms. So the objective of common tillage practices is to create a proper compaction level in the soil. Sometimes you have a plough sole. That plough sole may affect particularly the upland crops, and in that case you have to break that plough sole, and again we go for deep tillage, what we call as chiseling also. That's also a form of tillage. So we break down the hard layer, we loosen that hard layer, we reduce its bulk density, so that the physical environment remains a balanced one for the microbes to act and for a good availability of nutrients. Now just a little bit about soil compaction mechanism, or process of, better should I call as soil compaction mechanism. Now here, when we compact the soil, in fact we are closely packing the particles together. For example, you have this type of packing. So it will have certain bulk density. Say it is bulk density is X. When I compact this soil, maybe the packing system changes. So see over here. Now here bulk density, say it is Y, and Y is higher, I should say Y is greater than X. So just by rearrangement of the soil particles, you have compacted the soil. So here the particles are now closely packed. So in a compact soil, or compaction means close packing of soil particles, soil solids you can say, and this is indicated by change in bulk density and change in porosity of the soil. Now here I may tell you that when you have rearranged, you have compacted, this is you can say uncompacted, and this is compacted soil. Now when you have compacted the soil, of course there is rearrangement of the soil particles. Now there could be a change of total porosity, or there could not be change in total porosity. It depends upon the type of soil you have. If you have a very coarse textured soil and you know that macropores are dominating, so by compacting you have just converted macropores into micropores, and maybe the total porosity remains the same. So in that case, because of the rearrangement of the particles, I should say this is one particle and this is another particle over here, okay, and say it is another particle over here. Now when you are compacting it, that is compacting, so what happens? The particles could get rearranged in this manner. Now earlier this was the volume, now this is the volume. This is just a rearrangement of particles. So that's why I said that this change in bulk density or increase in bulk density by compaction could be change due to change in total porosity or no change in total porosity. But of course change in macroporosity and change in microporosity. Macroporosity may decrease, microporosity may increase. But if there is no change in total porosity, then how the total volume decreases? Just by rearrangement, because particles get closely, they come in close contact with each other like over here. So this is how the particles rearrange and the volume decreases. So that means when you compact the soil, total volume decreases. This decrease could be the decrease in the total pore space, what you call as porosity, or rearrangement of particles. These two things are important. That your volume, because you have total volume, bulk density, mass of solid, total volume. Total volume means volume of solids, volume of air, volume of water, or air plus water means volume of pores. So volume of solids that can be decreased. Otherwise, soil particles are not compressible. You cannot compress them. But because of the rearrangement of the particles, these soil particles, they get compacted. So there is decrease in volume, and that's why there is increase in bulk density. I hope the things are clear. So here I should say, when you are applying a dynamic load, under a dynamic load, soil, so following changes occur. When you apply load, first change will be that soil solids get compressed. So a compression of soil solids. But just now I said that soil solids cannot be compressed. Then why again I am saying a compression of the soil solids? It is simply rearrangement of soil pores. soil particles. That's why they get compressed. Second thing is there could be compression of gases or air, better like air and liquid or water within the pore space. Yes, air can be compressed, agreed. Water cannot be compressed. Then if you are applying pressure over there, then either the water may move out or a hydrostatic pressure could be created. So there could be some movement of the liquid from the pores, and if there is weight to the air, the compressed air may also move out of the pore space. So the third process is, then if there is movement of air and water because of the compression, then there could be a change in volume. A change in volume of air and water within the pore space. So either compression or change in volume. So when you compress, volume could decrease because air is compressible, water gets under pressure. So maybe then all the micropores they get filled with water. And lastly, there could be a rearrangement of soil particles. As I said, that a compression of soil solids, so that compression means the rearrangement of soil particles. Now if I explain this with diagrammatically, so before compaction, if this is a soil particle, this is another soil particle over here. So soil particle, this I shall better represent this as soil particle. So soil particle. And this is pore space, and say some of the pores that is occupied by liquid, say it is water, and similarly over here water, because of course water first gets, water when it enters into the soil, it makes films around the soil particles, and then it remains getting filled. Then in macropores it could be air. So in this case, this is uncompacted situation, uncompacted soil. So here, this is the point of contact, this one. This much is point of contact. Point of contact between particles. Now when we apply some force, when we compact the soil, the situation will become like this. So here this is soil particle, again this is soil particle, like this. So here now the point of contact has increased. So this is called compression of this is now point of contact. So earlier in uncompacted soil there was a small point of contact, but when you have compressed the soil particles, because of rearrangement or compression, the point of contact between the soil particles has increased, like you can see over here. If in this case this was the point of contact, now the point of contact is this one. So because of increase in point of contact, and again some of the this water has moved out, so here now the water content also decreases, maybe present in very small pores, micropores, and maybe air also gets compressed. So because of the compaction, this is now compacted soil. This is how compression of soil particles, soil solids takes place. So the pore water is displaced, it gets displaced, and area of contact between the two particles increases. And this of course is, this type of compression is elastic also. If you remove the force, then the particles may bounce back. So it could happen depending upon the type of soil you have. So the amount of liquid, as I said, may be forced out of the soil pores. That amount of liquid which is forced out of the pores, that will depend upon the magnitude of the load which you have. Higher the magnitude of load, more will be, then again type of soil particles, then again the bonding force or bonding energy between the soil particles and water molecules. If it's a sandy type of soil, then you can expect that the bonding energy between the soil particles and water molecules, that could be less, and more water may move out. So this is how the amount of water which gets displaced, it depends upon these three factors. Now when you have compacted the soil, if it's a saturated soil, that means majority of the pores are filled with water. So saturated soil, when it gets compacted, when you compact it, so what happens then? And compaction under dynamic load. I'm repeating here that dynamic load we are discussing, because this is the load which is generally most commonly observed in agriculture fields. So here the pressure generated. So when you compact the soil, there will be pressure generation. This pressure generated will be in the pore liquid, because it's a saturated soil. So water cannot be compressed. Say if whole of the pore is filled with water, a pressure will be generated, and maybe if water finds out its way, some of the water will move out of the pore. And when the volume of water decreases, so pore liquid, so here it will be liquid displacement. And when liquid has displaced, so there is decrease in, I should say better, decrease in liquid volume. And when this happens, then the hydrostatic pressure it gets transferred to interparticle spaces. Interparticle stress, that gets converted into. So that means, let me explain it with the help of a diagram. Now, say this is again, as I said, so you have water over here. So when you are applying pressure, say you are applying a dynamic load, so what happens first of all, that because it's a saturated soil, this is all filled with water, so some of the liquid will get displaced, liquid moving out. When liquid moves out, less water will remain inside the pores, so there is decrease in volume of liquid. Then this force, it is applied on interparticle, it gets converted into interparticle stress. Then these particles, they then reorient, and the point of contact between the particles increases. This is how the particles, they get rearranged. So here volume change now, the volume change due to compaction in saturated soil, it will be both because of, I should say, because of the movement of liquid plus rearrangement of soil particles. The rearrangement of soil particles, or you can say compression of soil particles. We can also use the word compression of soil particles. So this is how the process takes place in a saturated soils. So as I said, solid and liquid are incompressible, practically incompressible. The state of compaction, that is movement of these phases, soil particles, they move, they come closer to each other, water moves out, and that's why there is reorientation of particles. And what happens to the gaseous phase then? Because gaseous phase, it is compressible. And it follows simply the gas equation parameters, like you say the change in the volume of gases, this will be equal to RT divided by pressure plus additional change in pressure minus the original volume of the gases. So this will be the change in volume of the air, because air is compressible. Because of its compressible nature, it will follow the pressure volume relation of, so I should say pressure volume relations of ideal gases. So this was the case in in a compacted soil. Now if your soil is not compacted, it's a dry soil, and you try, if your soil is dry, it's not saturated, dry and pulverized soil. Pulverized means it's a loose soil, and when you compact it, now what will happen? It will not be compacted to such an extent. The extent of compaction will be less. Why? It could be because of the two reasons. One is because of the incompressible nature of incompressible soil particles, and second is because of the high internal friction. Because the soil is dry, so the internal friction will be high. It's a dry soil. So because of these two reasons, a dry soil cannot become compacted to such an extent as the wet soil is. Now when you add water into it, water addition, then the water films are found. Water films are created around soil particles, and those water films, they decrease internal friction. So it results in reduction in friction. It acts as a lubricant. So earlier the particles, they had very high friction rate. They could not rearrange themselves. They were incompressible because the soil was dry. But when water enters into within the two interparticle spaces, then this water acts as a lubricant, and then the particles, they get easily reoriented. So because of the rearrangement of particles, these soil particles, they become compressible. I should say they become compressible. So in nutshell, when your soil is dry, the soil particles are incompressible. But when your soil becomes moist or wet, the soil particles are they become compressible to such an extent. And when water films around, so one is there is decrease in friction. Second thing is that the force of cohesion between the particles. Earlier there was the two particles, there was nothing in between the two particles. So the force of cohesion was very high, And when water entered in between the two particles, the force of cohesion decreases. And because of this decrease in force of cohesion and decrease in the friction, the particles they slide over each other. Earlier the particles were like this because of the high friction, and when the friction decreases, there is decrease in force of cohesion, but the particles slide like this. So earlier this, now this is what we call as reorientation of the particles. Now here, if you remember, as I said, bulk density is this is mass of soil solids. It's only mass of dry soil and divided by total volume. Now if I ask you, will the bulk density of the soil be affected by moisture content? You will say no. Yes, you are right, because we don't have a moist soil, it's a dry soil, it's a dry bulk density. But even when you calculate the dry bulk density, I will say no, your answer is wrong. Moisture content, if you add water into the soil, the bulk density may increase. Now you will say, why it will increase? We are taking dry soil. So here, yes, we are taking dry soil, we are eliminating the moisture content from the soil, but because of the reorientation of the particles, there is decrease in total volume. There is decrease in total volume of the soil and bulk density increases. So even dry bulk density can be increased with the addition of water into the soil. And this is the reason, that the engineers, when they are creating the highways, they compact the soil, then add water, again compact it, then sprinkle water, again compact it. So that means when you are applying water into the soil, if this is your theta, theta is soil moisture content, and here it is bulk density. So when you are increasing the water content of the soil, I should say like this, the bulk density increases. Then a peak comes over here. So this theta, you can call it as theta p. After this peak, with further increase in water content, the soil compaction again starts decreasing, because now the soil behaves more like a liquid. So it loses, it doesn't bear any load. So its load bearing capacity decreases because of such high water content. So the moisture content at which there is maximum compaction of the soil, we call this as Proctor moisture content. And people say that no, this is not significance in agriculture, but I say yes, it is. The best example is your hard pan or subsurface compaction in paddy soils, because when we puddle the soil, when we wet till the soil, because again when you are tilling the soil, you are puddling the soil, you are disturbing just 10 to 12 or 13 centimeter soil, and below that the soil is quite moist. When the tractor is moving, it's puddling the soil, then the moisture, because of the moist soil conditions at say below 13 or below 14 centimeter or below 15 centimeter depth, the soil gets compacted to a greater extent than a non-paddy soil, because of the Proctor moisture content, because that sub layer 15 to 20 or 15 to 25 centimeter layer, that is getting moisture from the puddled soil, and it gets compacted because of the traffic, because of the flow zone, or we call this as subsurface compaction in paddy soils. And this is very, very important phenomenon in Indo-Gangetic plains. This subsurface compaction, it could be good for the paddy crop, but it's not good for the upland crops. I have very easily explained this concept in my beginning, in my first lecture, where you call it as, we call this as aeration stress. So I hope the things are clear. So this is how the process of compaction, it affects agriculture, crop production. Thank you very much.